Hello everyone, welcome back. It is time for our next set of notes over chemical properties and interactions. Let's start first with some definitions. A molecule is when two or more atoms combine chemically and form a bond. We have been talking in class about how electrons are arranged on an atom. Where these electrons are arranged is very, very important because of bonding. So in the case of water, when we have one oxygen atom and two hydrogen atoms, they come together to make H2O water because oxygen in its outermost ring only has 6 electrons. We know it takes 8 electrons to be full. If you add one hydrogen with 1 electron and another hydrogen with 1 electron, we now have 1, 2, 3, 4, 5, 6, 7, 8, and the energy level is full, and that's why it bonds so easily. Some more definitions. A pure substance. A pure substance is only made up of only one kind of atom or molecule. For example, pure water is only H2O. It's only one kind of molecule. Minerals like graphite and diamonds are also made up of only one kind of atom or one kind of molecule, so it is a pure substance. Pure water is just H2O molecules, nothing else included, so it is considered a pure substance. Another important vocabulary term is a compound. A compound is when two or more elements combine chemically but have properties different from the elements that they're made of. For example, hydrogen and oxygen. They're usually gases at room temperature, but when they combine at room temperature, they form a liquid because at room temperature, water is a liquid and not a vapor. A mixture is when two or more substances combine physically but not chemically. For example, we have items in a fishbowl. You might have a fish, a plant, some rocks. They're all together, but they're easily separated. I could reach in and I could pull out the rocks, I could pull out the plant, and I could put the fish in a net. So it's easy to separate out those things. Even things that don't seem so easy to separate, like a glass of sugar water. I could sit there and let the water evaporate, leaving all the sugar crystals behind. They're not combined chemically and then can be separated. So this is called a mixture. Back in 6th grade, we did some conversations and did some activities about physical and chemical properties. Physical properties are any properties you observe by using your senses. Examples of physical properties are states of matter. I can see when water, for example, is a solid, as ice, a liquid as water, or gas as a water vapor. I can smell, I can taste, I can see color. These are all physical properties of something. Chemical properties describe the ability of a substance to do something. For example, how flammable is something, or how combustible. How rustable is something as well. These are all chemical properties, the ability of something to be done to an object. Let's discuss what exactly happens during a chemical reaction. In a chemical reaction, molecules change through the rearrangement of the atoms. Atoms of the reactants, that's what's happening on the left-hand side here, rearrange themselves to form new molecules. So here's an example of a chemical reaction. This is called methane. Methane is made of 1 atom of carbon and 4 atoms of hydrogen. When methane comes into contact with oxygen molecules, the molecules break apart and rearrange themselves to become carbon dioxide and water. Here's how we show the chemical equation for a reaction. The chemical equation is written kind of like a math equation, except instead of using just numbers, we use numbers and letters and can even show the rearrangement of the molecules. The reactants are always on the left-hand side. In this case, our reactants are carbon, hydrogen, and oxygen. Methane is CH4, and then we have oxygen in the form of 2 O2 molecules. All of these molecules break apart and then rearrange each other to make new products. The carbon is still there, but now instead of being with some of the hydrogen, it's rearranged itself to be with some of the oxygen molecules in the form of CO2. Some of the rest of the oxygen combines with the hydrogen in order to form water molecules. The arrow means produces or are converted to. Let's see what happens when we have these molecules actually react. So let's actually see when methane and oxygen are ignited. Let the Mythbusters show us what happens.
With the room filled with 9% methane, will this finally yield the Hollywood blowout?
All right, here we go. Ideal gas-air mixture, born explosion in 3, 2, 1. Oh, yeah! That is awesome! We blew out the whole front!
Yeah.
That was a pretty awesome explosion clip. I hope you notice after that building blew up how you could see the steam and the smoke coming from the top of that building. That steam and that smoke were made of carbon dioxide and water vapor. So you could see the reactants, the methane gas inside, and then you could see the products that were created from the explosion. That was a pretty cool explosion, but let's try writing out a more simple equation on our notes. For example, H2 plus O equals H2O. 2 atoms of hydrogen plus 1 atom of oxygen creates 1 molecule of water. A very simple chemical equation. Scientists can confirm that a chemical reaction has happened by seeing if a new substance with new properties has formed. One of these signs is a production of a gas. For example, we've all probably done that science experiment where you create a volcano in elementary school. That volcano is created by using baking soda and vinegar. Baking soda and vinegar give off several products from those reactants, but one of them is carbon dioxide gas. In case you forgot, here's a clip. Another sign that a chemical reaction has occurred is the production of light. You've all seen burning logs, seen a fireworks show, and I'm sure you've played with glow sticks. But have you ever wondered how glow sticks actually work? Check out this clip to find out.
Hey, it's me, Lauren. You've seen glow sticks before. They bring a festive glow to Halloween trick-or-treating and New Year's Eve celebrations, and they're useful gear for explorers from scuba divers to spelunkers. When you find a bunch of people gathered to party in the dark, at least a few of them will probably be wielding glow sticks. But what the heck are these things? How do they work? Glow sticks are powered by a process called chemiluminescence. Don't let the name scare you. Luminescence is just a fancy word for any emission of light not caused by heating. The chemiluminescence in glow sticks is a pretty simple reaction caused by mixing chemical compounds. Compounds are made up of different elements bonded together in specific proportions so that they can't be mechanically separated. It takes a chemical reaction to sort out, for example, the oxygen from the hydrogen in water. When you mix a compound with other stuff, you can set off that reaction. And as the atoms rearrange themselves, they'll either absorb or release energy. If you look inside a glow stick, you'll see that there's a small glass vial in the tube. This vial typically contains a hydrogen peroxide solution called the activator. It's floating in a solution containing a compound called phenyl oxalate ester and a fluorescent dye. When you snap a glow stick, the vial breaks, and the hydrogen peroxide reacts with the phenyl oxalate ester, creating 2 other compounds, phenol and peroxy acid ester. Still with me? Good. The peroxy acid stuff is unstable, so it decomposes and produces additional phenol. It also produces a cyclic peroxy compound, which decomposes to carbon dioxide. This decomposition releases energy to the dye. The electrons in the dye's atoms jump to a higher level, then fall back down, releasing energy in the form of light. The other chemicals in the fluorescent dye determine the color of this light. Now, all of this happens within moments of snapping and shaking your glow stick. Depending on which compounds are used, the chemical reaction can continue for anywhere from just a few minutes to a few hours.
More proof that a chemical change has occurred is a change in temperature. Have you ever had one of those hot hands hand warmers? When you mix up the contents of the bag, a chemical reaction occurs, releasing heat. Also, the formation of a precipitate. A precipitate is a solid substance that forms from a solution of liquids. So sometimes you have two liquids, but when they mix together, all of a sudden a solid solution appears. And finally, a change in color. We've all seen rust before on a nail, on an old chain, but when a change in color occurs, that is usually a sign of a chemical reaction occurring. Well, thanks for watching. That's all for this time. Have a great day.